Hi everybody. So I want to continue working with the same data set that we were working on in Zoom today, namely data from the West African Ebola outbreak in 2014-2015. So here's a plot of the data graphed over the year, the course of the year of the outbreak that we looked at this data in class. So we kind of left things with a cliffhanger in class, and I want to wrap up that cliffhanger. And if you recall, in class, we ended discussing this problem. So there were 548 new cases over the first week in December of 2014, 78 new cases over the course of the week in mid-June of 2014. And we were talking about which of these increases seems more significant. And so using average rate of change as a measurement, we could calculate these two average rates of change. So for example, in the first week of December, cases were growing at an average rate of 78 cases per day. And so this 78 comes from taking the total change in cases, which was 548, and dividing that by 7, which was the total change in time over that week. So that was a change of 78 cases per day. And if we did a similar analysis of what was happening in June, we saw that in that week in June, that cases were growing at a rate of 11 cases per day. So in terms of absolute terms, yes, there were more cases being reported in December each day than we had in June. But the question is, does that tell us the full story? And so to see what these calculations look like visually on the graph that we just did, these average rates of change, in November 30th, the 78 cases per day, November 30th was 250 days after the outbreak. So we're looking at things right around here. And we can see that this is pretty steep graph compared to the graph over here, which started out flatter. So June 10th, it was about 77 days into the outbreak. So the fact that the graph is steeper over here tells us that there were more cases being reported each day over this period of the spread as opposed to at June 10th. And so in class, when we were trying to consider which of these changes was more significant, we discussed the fact that we're missing some context based on the information that I gave you, namely, like how many cases were already reported at that time. So to see why just comparing absolute changes might be confusing or misleading, we can think about, well, let's consider what would be a more noticeable change if all of a sudden 1 million more people joined the population of China, or whether we had 200 new mid-career students all of a sudden join the program. So in absolute terms, certainly the 1 million people is way more noticeable than the 200 students. But China's population, there's over 1 billion people in China, so an increase of 1 million really wouldn't be all that noticeable as compared to saying we have less than 200 mid-career students in the class this year, and so if you increased that total by 200, that would be way more noticeable. All of a sudden, we would have more than double the amount of mid-career students. So we want to have some additional context here if possible. And so when we're comparing changes like populations to two very different sized groups, like population of China or the number of mid-career students, we don't want to compare absolute changes. It oftentimes makes more sense to compare percent or relative changes. So let's add this component to our analysis with the Ebola data. And so if we want to compare relative percent changes in our analysis, then what I would need to know is, well, how many cases were there at the start of that period on November 30th? How many cases were there on the start of the period on June 10th? So for example, in December, we were much further into the spread of Ebola, so there were lots more cases. There were over 10,000 cases reported at that point. In June, it was much earlier in the spread of the disease. There were 544 cases that had been reported at that point. So let's calculate, based on this information, what were the percent changes over these 2-week periods. So in the gray box, we have defined how we can calculate percent changes, relative changes in output. So notice in this formula, there's no indication about how much time has elapsed. So the only thing we're calculating here is how much did our output change, in this case, how many additional cases were reported, and then we divide by, on the bottom, relative to how many cases, what was the value of the output at the start of that period. So it's going to be change in P, change in the output, divided by what the initial value of the output was. So in the case of looking at the spread of Ebola from November 30th to December 7th, we started with, on November 30th, 10,738 confirmed cases. Over that course of the week, the change in the cases was 548. So this calculation for the relative change would be the change in P, which in this case, the change in the output were the total number of new cases. So the cases increased by 548 compared to, well, how many cases were there at the start of that period? So there were 10,738. So the change in P is the 548. The initial value of P for this period is 10,738. And taking that quotient gives us 0.051. And here, we're calculating a percent change, right? So the units on the numerator, the top of this fraction, are confirmed cases. The units on the denominator are also confirmed cases. So the units cancel out, and what we've calculated here is a percentage change. So this 0.51 is also, if we convert that to a percentage, that would be a 5.1% increase. Okay, so this relative change tells us over that course of the week, this would be the first week in December, the number of confirmed Ebola cases increased by 5% over that week. And now let's calculate a similar relative change in the number of cases in mid-June, so much earlier in the spread of the disease. So over this course of 1 week period from June 10th to June 17th, in this case, our total change in cases, we're told that we had 78 new cases, and this was out of an initial number relative to 544 cases as of June 10th, 2014. And so calculating this ratio, this gives us a change, a relative change of 0.143. So in other words, if we convert that decimal to a percentage, this is saying that there was a 14.3% increase. And so let's summarize all of this information, both the absolute rates of change that we calculated in class, and let's see how we can make sense out of these relative rates of change that we just learned about how to calculate. Okay, so summarizing together these average rates of change and the relative rates of change. So in class, we pretty much did this sort of analysis where we said in that first week of December, there were 78 cases on average per day, compared to in mid-June, there were an average of 11 cases per day. So in absolute terms, it would seem like the cases were increasing more significantly in the first week of December as they were in mid-June. But because the total number of cases that were reported at each of these periods is on a totally different scale, because one is very early in the spread versus one being very much in the middle of the spread, we would want to do some more analysis. And so if we now incorporate these percent changes that we calculated, we now could say, in addition to what we first observed about average rates of change, in the first week of December, the total number of confirmed cases grew by about 5%, compared to in mid-June, the number of cases grew by about 14% in that week. So this 78 cases was actually quite significant compared to the fact that about 500 cases had only been confirmed up to that point. So that's a pretty significant jump percentage-wise compared to when there were over 10,000 reported cases on November 30th. An additional 550 cases, certainly that's not a good situation, but that's a less significant increase percentage-wise than what happened over the course of the week in June. So here, certainly the more information that we can say, the better. So it's good to keep in mind both the absolute rates of change and the relative rates of change. And we hear both of these things quoted all of the time when we're, for example, hearing about the spread of coronavirus. And so that's a wrap for the material. I just want to leave you with one thought. So you've got a quiz on Canvas that you're going to need to work on. And that is when you're calculating relative percent changes, then the very first thing that we need to do, if it's not already done for us, is to calculate the change in P, this delta P, by taking the end value of the output and subtracting the initial value. After we have that change in output, we then divide by the initial value of P. So in the examples that we did, the change was given to us. We were told how many new cases were reported. In some of the examples that I might ask you to do, you might just be given what was the initial value of P, what was the end value of P, and asked to calculate the relative change. So just be sure that first you calculate how much P has changed, then you divide by what the initial value of P is. But give the quiz a chance, and if you have any questions, we'll talk about this in class on Friday.